All right, as people trickle in, I think we will get started and people can join as the presentations are going on. So welcome to today's webinar with National Research Council, Measurement Canada, and Transport Canada. Oh, there it is. So before we begin, I'd like to give a little introduction to who the Canadian Hydrogen Association is for those of you who don't know us. The Canadian Hydrogen Association, or the CHA, is a national-wide industry association established in 2009 with over 180 members. We have provincial affiliates in British Columbia, Alberta, and Ontario. Excuse me. And we work closely with the Atlantic Hydrogen Alliance and Hydrogen Quebec. As the voice of the sector, we work closely with our members on advocacy efforts, government relations, both federally and provincially, and facilitate communications and networking efforts between our members and the greater international industry. So these are all our wonderful members, and if you're interested in learning more about membership, I'll be sending an email out to all registrants after this webinar, and you can feel free to respond to me then. Before I introduce our speakers today, I'd like to have a quick call to action. The CHA is working to create a Canadian hydrogen sector profile that will give an in-depth overview of Canada's hydrogen ecosystem and help guide our policy, advocacy, and government relations efforts for the coming year. All data collected is 100% confidential and is being handled by our partners at iTotem Analytics, so even the association will not see any of the data that you put in the survey, and all of the data published will be an aggregate number. So nothing will actually be put out specifically for your organization. Right after I stop sharing my screen, I'll drop the link in the chat and would really appreciate it if each of your organizations could fill it out if you already haven't done so. Now, moving into the real reason we're all here today, I'd like to introduce our speakers today. So Annie-France Carrière is a senior engineer acting as a research and development agent at Transport Canada under the road section of Transport Canada's Innovation Centre. There, she is leading the implementation and delivery of interdepartmental collaboration research projects on zero-emission vehicles, advanced engine technologies, and automation, cybersecurity, and connectivity. Jennifer Little-Jones is a biochemical engineer who has over 15 years of experience in the areas of clean energy and health in Canada and abroad. In her current role as Program Director for the Advanced Clean Energy Program at the National Research Council, she manages a program focusing on battery energy storage, hydrogen, and biofuels R&D. Cyril Desipeti is a Senior Research Council Officer at the National Research Council. He has been at NRC since 1998, and over the last 15 years, he led the development of data management platform for analyzing novel energy technologies, such as grid-connected energy storage and hydrogen distribution for fuel cell cars. Using this platform, Cyril has led several projects focused on metering error, reliability, and mass balance of hydrogen dispensing for light-duty vehicles. And lastly, Jeremy Mann is a senior gas engineer with Measurement Canada. He has over 25 years experience with environment and climate change, working in emissions and environmental research in the clean air sector, regulation development, and overseeing assessment and approval of gas measurement equipment. So with that, I will stop sharing my screen and pass it off to our first speaker, Annie.
Yes, hi, thank you. I will share my screen. And we'll get started. Great. So hi, everybody. I've been introduced, but my name is Annie-France Carrière. I'm a senior engineer acting as a research development officer at Transport Canada's Innovation Centre. And I'm happy today to present on behalf of my team. Today, we'll quickly introduce the Eco Technology for Vehicles program. So that's the program that I work for and our research projects. We'll also highlight ongoing activities related to hydrogen fuel cell vehicles. Without further ado, let's get started. So we'll start with a short description of the work that our department and our program do in relation to zero emission and fuel cell vehicles. So the Government of Canada has taken a collaborative department-wide approach to decarbonizing the on-road transportation sector. Transport Canada, that are often referred to as TC, is responsible for transportation policies and programs and promotes safe, secure, efficient, and environmentally responsible transportation. As such, three of TC's focus are vehicle safety and occupant protection, efficiency on transportation modes and their systems, and decarbonizing the transportation sector. In the past, the department was actually focusing mostly around vehicles themselves, but now the scope of transportation research has expanded to consider the supply chain and the full life cycle of a vehicle. So TC is currently supporting the commercialization and uptake of zero-emission vehicles by first assessing the safety performance of ZEVs, expanding incentive programs, and also supporting research, development, and demonstration efforts. One partnership worth mentioning towards that goal is the Canada-US ZEV Task Force. So this working group has been involved with several activities such as establishing binational zero emission corridors, harmonizing codes and standards, and developing a zero emission bus toolkit. As part of TC, the Eco Technology for Vehicles program, so the ETV program, exists under the Pan-Canadian Framework on Clean Growth and Climate Change. And the program tests and evaluates the safety and environmental performance of advanced vehicle technologies with the goal of advancing key Government of Canada priorities. More specifically, our program has three goals. So first, support the development of future vehicle emission regulations, including zero emission vehicles, such as obviously hydrogen fuel cell vehicles, and key infrastructure to support that technology. Second goal is to inform the development of safety approaches to new clean technologies. And third goal is to establish non-regulatory industry codes and standards to integrate new vehicle technologies. So obviously, ETV is managed by Transport Canada, but the program serves as a federal research development and demonstration initiatives that supports the safe and timely integration of clean technologies across Canada's on-road sector. So obviously, we work closely with many other federal departments. That includes Environment and Climate Change Canada, Health Canada, the Innovation, Science and Economic Development Canada, Natural Resources Canada, and the National Research Council. Our ETV program works on a continuously renewing 3-year work plan. So each work plan is developed through consultation with stakeholders within and outside the federal government to identify research priorities and key knowledge gaps for the transportation sector. The current work plan has actually started last month and will be supporting 24 projects across 4 technologies areas in the next 3 years. Well, for this work plan. Our project dive into both the light duty and the heavy duty vehicle sectors. And just to quickly cover or provide an overview of those 4 areas, I'll start with the last one. So category D is automation, cybersecurity, and connectivity. So those projects investigate technologies such as advanced driver assistance system or ADAS and vehicles to vehicles technology, V2V, just to name a few. Category C is about tire safety and efficiency. Just to give an example, we are looking at particulate matter emissions from non-combustion sources. Category B is on vehicle efficiency and aerodynamics, and we're doing some testing with NRC's wind tunnel. And finally, category A, which is the most relevant for today's presentation, is zero emission vehicles and advanced engine technologies, which holds about half of our projects and covers many subjects. Our 3 hydrogen-related projects are found under this category and are listed on the slide. So the first one looks into the performance of vehicles in different conditions. We have tested a hydrogen car, and we're looking at testing more in the future. The second project, crashworthiness, is to test vehicle and occupant safety in crash situation. Unfortunately, we haven't yet crashed a hydrogen vehicle, but we are definitely planning on doing so. And finally, the third project is about the reliability and accuracy of hydrogen refueling station. On that last project that I just mentioned about the refueling station, we are collaborating with the NRC to collect and analyze data from commercial retail hydrogen refueling station in Canada. There are currently 6 refueling stations in the country. So one is in the province of Quebec and the remaining 5 are in British Columbia. More stations are actually to be built in British Columbia in the next couple of years. But currently data from the 5 existing British Columbia station is collected by the NRC to investigate reliability and accuracy. The goal is to understand the reliability and accuracy of hydrogen refueling, also build user confidence for hydrogen vehicles, and recommend testing approaches to evaluate hydrogen refueling technology. The NRC will further elaborate on that during their presentation, so I will just keep it at that for now. The federal government and the entire transportation sector have been quite active in integrating zero emission vehicles in order to reach its climate objectives. So, up to now, however, most of the work has been focusing on light duty vehicles, but the need to expand to the heavy duty landscape is becoming prominent. And that's why the interest in hydrogen is also growing. If we look at the battery electric vehicle side, we have the American National Standards Institute and the Canadian Standards Association Group. They have both released roadmaps that have identified key research and standard gaps related to the deployment of EVs. There are many ongoing research evaluating battery durability and real-world performance. If you look at the hydrogen fuel cell vehicle side, the NRC has completed a gap analysis to obtain information from hydrogen suppliers and from the industry, and also to promote alignment of standards development. And there's a working group on hydrogen codes and standards and many research on refueling. And finally, if we look at zero emission vehicles in general, TC is participating in international working group. TC is supporting codes and standards and infrastructure programming. And we also want to better understand the hydrogen supply chain and the whole electric vehicle lifecycle. Transport Canada also undergoes many activities related to hydrogen needs refueling. So just to provide a quick overview of those activities, we first have the decarbonization of the transportation sector because hydrogen will play a key role. Some of the new stations to be built in BC will be for commercial heavy-duty vehicles, and TC is interested in expanding the research to that area. We also support the development of hydrogen technology. The diagram on the right kind of shows all the activities that are ongoing, but just to mention some of the key ones, we inform stakeholders on the knowledge gaps and barriers. We also communicate regularly with the industry, and we focus the research and policy efforts. I've quickly mentioned it when I talked about our projects, well, the ATV projects, but vehicle safety of hydrogen cars will be investigated. So that's another activity. We're planning on evaluating the occupant protection of all zero emission vehicles, and that include hydrogen vehicles. Also, the different projects that we support feed into the UNEC Global Technical Regulation on Hydrogen. So that's GTR number 13 more specifically. And we also take input from other jurisdictions to gain knowledge from their greater experience. One example is our collaboration with Germany through the German-Canadian High-Level Steering Group on Bilateral Cooperation. And finally, metrology of hydrogen refueling station is another key subject with ongoing activities, but I believe Measurement Canada will be talking about that in their presentation. So again, I will leave that to them. Before I conclude, hydrogen is a key player, is becoming a key player in the climate objective. So we just wanted to highlight some of the emerging priorities. We have the standardization of hydrogen dispensing requirements. Another priority is to get a better knowledge of the cold weather effects on reliability and performance of both the hydrogen vehicles and their refueling infrastructure. We also want to investigate the safe and reliable deployment of medium and heavy duty zero emission vehicles refueling infrastructure. And another priority, and that's actually a priority across the whole transportation sector, so not only what's hydrogen related, is to understand the cybersecurity of the zero emission vehicle charging ecosystem. To conclude, we have included here a few additional links and resources about zero emission vehicles. Across the government of Canada, there's a zero emission vehicle hubs that exist, and TC's programs are part of it. So that's our ATV program, but also the zero emission trucking program. Transport Canada also has a few incentives programs to encourage ZEV adoption, both at the light and heavy duty levels. And we've included a link of TC's related publication. So that would be it for our presentation today. So you've got my email address on the slide, also my manager's email address on the slide if you ever want to reach out. I believe there will be a Q&A section at the end of the webinar. So we'll be happy to answer to your question at that moment. Thank you.
Thank you, Annie. I think next up is Jennifer. At the end of these presentations, we will be having a Q&A session, so please hold your questions during then, and you will be able to turn on your mics and cameras. Jennifer, please share your screen.
Great, thank you so much. Can you see my screen and hear me?
Yes.
Perfect. Great, thanks so much, and hi everyone. My name is Jen Littlejohns, and I'm the Program Director for the Advanced Clean Energy Program at the National Research Council of Canada. And today I'm really happy to provide you with an overview of one of the programs at the National Research Council that has a focus on hydrogen. And I'll give you an idea of some of the activities that we're undertaking. Okay. First, just a little bit of background about the NRC. We're Canada's largest federal laboratory, and we have over 2,000 scientists, engineers, and technicians across Canada at various sites and locations. We're very highly collaborative and work with industry as well as academia, and of course, government departments, as Annie mentioned, to conduct R&D both within Canada as well as abroad. And there's two sides to the NRC. One side of the NRC is the research centers, and that's where the part that I belong to. The research centers conduct research and development and work with partners and clients to complete projects on various topics. So we have 12 different research centers across the NRC that focus on different topics. For example, everything from digital technologies to oceans to aerospace, and clean energy innovation. And clean energy innovation is the research center to which I belong and where this program I'm talking about is located. There's the other side of the NRC, and that's the Industrial Research Assistance Program. So that part of the NRC is the one that delivers funding to small and medium-sized enterprises across Canada to conduct industrial research and development and to grow companies. So within our research center side, within the federal laboratory side, we have 26 different R&D programs. And each program looks across the NRC and draws expertise in order to deliver on a specific mandate. And it's often highly collaborative, as I mentioned, with industry and with government and academia. And the purpose of these programs is to guide the R&D into a strategic area and determine the needs for industry and government and deliver on innovation in these areas. So I'll get into the program now. One of these programs that I mentioned is the Advanced Clean Energy Program. This is the one that I'm responsible for. And this program in particular has over 65 different projects where we partner very heavily to conduct R&D in the mid and high technology readiness level range for clean energy technology development. So the concept behind what we're doing here is to develop clean energy technologies that are not just for one end use application, but those that can be foundational for the up and midstream supply chains and enable multiple sectors to mitigate emissions and meet Government of Canada emission reduction targets for 2050. So this is providing the supply chains for clean energy technologies that are applicable to, for example, marine, aerospace, surface transportation, and even stationary power. So in this program, we have 4 different key focus areas. The first pillar is on our battery energy storage pillar. We're looking at mineral processing, battery recycling, and materials discovery for batteries. The second pillar is the low carbon fuel switching pillar. So here we're conducting R&D in low carbon fuels production and utilization, such as biofuels and internal combustion engines, and how we can use our current infrastructure to reduce emissions more for the near term. And then our third pillar, which is really going to be the topic of what I discussed today, is our hydrogen pillar. And here we're looking at conducting R&D in hydrogen production and how we move hydrogen around, so how it's distributed and transported to the end use. And finally, our last pillar in the Advanced Clean Energy Program, or the ACE program, is focused on renewables integration into microgrids to validate and test different renewable technologies and integrate them effectively into energy systems. So our pillar 3, our hydrogen pillar, this pillar is designed to support Canada's hydrogen strategy, and particularly in the midterm to long-term goals. In particular, the hydrogen strategy for Canada states that the hydrogen production must be reduced in cost as well as lowered in carbon intensity. So we're focusing on production technologies that can do that. And in addition, we're looking at distribution and storage infrastructure development, which are key aspects of the hydrogen strategy as well. So we're also working to support this area. And as it's stated in the strategy, we really do need sustained R&D across from the near term all the way to the long term to ensure that that we can do the job. So that's what we're doing in this program, looking at those two areas and supporting policy really through providing data and information as well. So this brings me to the focus of our hydrogen pillar. There's 4 areas that require the focused R&D to enable the hydrogen economy. In the production area, one area we're investigating is the key requirements for membranes for water electrolysis, both for PEM, proton exchange membranes, as well as anion exchange membranes. We systematically investigate membrane defects, for example, in some of our production projects, as well as looking at testing platforms to really get the technologies validated. To enable safe and efficient distribution of hydrogen, we're looking at codes and standards, as well as infrastructure requirements and/or failures for pipelines. And Cyril will talk about refueling stations as well. That's a really important component of this pillar. And finally, we're looking at developing decision-making tools, such as life cycle analysis for hydrogen production pathways, and as well gaps analysis for hydrogen codes and standards. That's all under this area of work. And we do have really long-standing capabilities in R&D and hydrogen across the NRC. There's 4 sites in particular in Ottawa, Vancouver, Montreal, and Mississauga, where we have a lot of capabilities applied to hydrogen. Everything from our low technology readiness level materials discovery for electrochemical hydrogen production to much higher TRL for our testing platforms and materials testing for pipeline blending. Those facilities are located in Vancouver. Also in Vancouver, there's a really long history with the former Fuel Cell Institute. And then in Ottawa too, with our Aerospace Research Center, looking at hydrogen and turbines for power generation. So in short, there's a lot of different capabilities in hydrogen at the NRC that we draw from. And it's not just the Advanced Clean Energy Program looking at this, but there's a lot of other programs across the value chain. And I'm really happy to put you in contact with some of the leads for these different programs if there's interest. For example, the Materials for Clean Fuels Challenge program. That's a really highly collaborative program aimed at materials discovery for our low emissions aviation program, or LEAP program. They're interested in hydrogen technologies as applied to aircrafts. Our clean and energy efficient transportation program is interested in hydrogen as applied to surface transportation, for example, fuel cells. So there are different key focus areas and different programs as well that we work with. So just a couple example projects. I won't share the example of Cyril's project because he will talk about that in more detail, but just a couple other projects that I wanted to mention that could be of interest. One is the life cycle analysis of hydrogen production pathways in Canada. This is being led by Giovanna Gonzalez-Calian, who's actually giving a webinar next week on this. So if you're interested, then please join that. But in short, the scope of the project is related to, in Canada, hydrogen production is informally categorized by color associated with its production methods. And this leads to preconceptions regarding its carbon intensity. But these preconceptions can be misleading and the carbon intensity really should be quantified using standardized, transparent life cycle approach instead of its color. So under this project, it aims to really remove the color categorization of hydrogen and quantify the carbon intensity using life cycle analysis approach of various production pathways for hydrogen in Canada. And for this project, we're working with several different university and government partners, and the outcomes allow for decision making on investments and what are the best hydrogen production pathways that we should focus on in Canada. And then finally, just another example project that's currently underway is our hydrogen codes and standards gaps analysis. So this is being led by Manuel Hernandez, and it's a very interesting project looking at different hydrogen pathways across the supply chain. You can see here, this is just one snapshot of the many different various pathways that he's looking at. And he's looking at hydrogen codes and standards within different segments of the supply chain and diving in to see what codes and standards exist, where there are gaps, and who are the key players and stakeholders that need these standards. So this project then aims to point in the right direction of the low-hanging fruit to tackle for codes and standards to enable the supply chain really efficiently and effectively. So that's it from me. I hope I've given you a good overview of what we're doing in the Advanced Clean Energy Program, and please do reach out if you're interested. And with that, I will hand it back over.
Thank you, Jennifer. Our next speaker is Cyril.
Thank you very much. Can you see my screen?
Yes, we can see it. If you can put it in presenter mode.
Sure.
Yep.
Well, thank you very much. My name is Cyril de Sepetti, and I will present you our project about a hydrogen refueling station in which we try to estimate the metering error by analyzing the data logs generated by the hydrogen refueling stations in Canada. And so the metering error is actually composed of precision and accuracy. Precision is, as you can see in the little graphic, is how repeatable is a fueling event. And on the left-hand side, you have a very precise dispensing, and on the right-hand side, you have like a very scattered, low precision dispensing. The second component is about accuracy. So when you are exactly in the target of your metering mass, you are very accurate, but you can have also some bias during dispensing, and that can be revealed even when it is precise or when it is scattered. This being said, we first look at the precision of fueling events. So in that regard, we use the least absolute shrinkage and selection operator, the lasso regression. Using that lasso regression, we identify the mass count, so the amount of hydrogen delivered, and the flow rate, the nozzle pressure, and the nozzle temperature as the main variable to analyze. It was found that the inclusion of additional variables besides the four mentioned failed to improve the results or even worsen the results. Then, using those variables, we cluster the fueling events using a soft dynamic time warping. And so we identify 6 different clustering schemes. And of course, we try to optimize the clusters using the AKK information criteria. And so this is to evaluate how well a model fits the data it was generated from. And so we based this optimization on the number of fueling events in a cluster and analyze the mean and standard deviation of the hydrogen amount, as well as the average fueling duration and the average initial state of charge. We did remove from the clusters any fueling event that is less than 10 seconds in duration, as well as delivering less than 100 grams of hydrogen. So when when reviewing the results of clustering, here we are representing the cluster in different colors according to the fueling time and to the mass delivered. So in a particular fueling stations, we can see a cluster very well defined, and even though scattered, but this the optimization reveals it is a very comparable results. However, in another refueling station, we have some cluster very well defined, while a couple of cluster, like the cluster number 1 and the cluster number 5, are very overlapped. So while some refueling stations exhibit clear separation of clusters when considering the mass dispense, cluster tends to overlap in other stations. And this can be done due to the dynamic time warping that is sensitive to alignment of time series, and which means that slight variation in alignment can lead to overstretching or overcompression when measuring distance between trajectories, which can significantly affect the clustering results. So this can need to be kept in mind when like analyzing the results. So mainly the results here should be taken as a in relation to each other, not in an absolute values. So when refueling a car, the station will use the T40 temperature control. However, when the fueling delivery temperature might not be maintained at the desired level, which is below minus 33 degrees Celsius. And this can be due to equipment limitation or environmental factor. Then a fallback procedure would occur to a T30 temperature control or even a T20 temperature control. So when comparing those two temperature control fueling events, and we observed that a better metering precision was obtained when refueling cars at a T30 temperature control. So in all clusters, like the cluster 5, 6, 7, we have only T30 fueling events, and with cluster 8, 9, and 10 are also better accuracy, better precision for T30. Similarly, we did fueling event analysis in regard to the different size of cars. So when analyzing the fueling events, we observed that there was tank volumes of 122 liters and 159 liters. And so we observe that fueling events on cars using 122 liters tanks have a better precision than fueling on 159 liters. Now I will introduce you the methodologies that we use to evaluate the accuracy of the dispensing of hydrogen. So we use on one side the pressure, volume, temperature method. As input, we use a vehicle tank volume, and we use a tank temperature and pressure at the end of the fueling event. So this information are transmitted from the car to the fueling station at the time of fueling. And the output is a hydrogen mass in the vehicle tank. So there is some wild assumptions here. So first is we assume that the temperature and pressure measurement in the vehicle tank are correct. The temperature in the vehicle tank is uniformly distributed. And the equation used to calculate the mass density of hydrogen is correct and valid for the temperature and pressure range in this operation. And at the time of observation, the vehicle tank has reached a steady state thermodynamic condition. And so these assumptions are generally not met, but thermodynamic models remain the best option in our current situation. So when analyzing the metering accuracy data, we compare, we use the Dirichlet process mixture model, or DPMM, for clustering the fueling events. So this model offers the advantage of discovering the number of clusters automatically. And so those clusters are represented in this graphic. And it was observed that one station was overestimating the mass of hydrogen dispense for 122 liters, while underestimating for 159 liters. There is another station that is underestimating for both type of cars, while the two other stations we reviewed were slightly overestimating the mass dispensed, and for both 122 liters and 159 liters. And the achieved accuracy was 2.15% to 2.88%. Finally, we tried to evaluate if there was any seasonal variation of metering accuracy. But in both 122 liters and 159 liters, we tend to observe some variations for the 159 liters, but as you can see, there is too much variance in the data to draw any significant conclusions in that 18 months observation window. On this, I will end my presentation, and I will pass on to Jeremy.
Thanks, Cyril. Let me just share my screen. So I think I was introduced at the start, but I'm Jeremy Mann, the Senior Gas Engineer with Measurement Canada. I will go quickly, so I leave lots of time for questions at the end. But if there's something I miss, please reach out to me afterwards. I'm happy to talk. So Measurement Canada is part of Innovation Science and Economic Development Canada. We oversee two main acts, the Weights and Measures Act and the Electricity and Gas Inspection Act. And basically, we're trying to maintain a fair marketplace where accurate measurement is done of any products that are available for sale. So the main one that affects the majority of the group here and that I'm most interested in is the Electricity and Gas Inspection Act. So it defines the measurement and sale of gas, and that includes hydrogen and other gases. What it does is it prescribes mandatory calibration, type approval, and then future verification and sealing of any equipment used to measure gases that are used in trade. And the primary emphasis has been on natural gas. It's a new field to look at hydrogen and alternate fuels. So really, our legislation, we've needed to make changes to figure out how to handle handle alternative fuels like hydrogen. And certainly that's kept me busy over the last little while with updates required to how to handle hydrogen. And just in case anyone's interested, manufactured gas, that would be like coal gasification would have been town gases that would have been used quite a long time ago, but they're different from natural gas. So many of the speakers have talked to a lot of the work that's underway. The government's put a lot of effort into hydrogen and supporting alternative fuels. A good chunk of that has been zero-emission vehicles and the infrastructure involved in fueling those. That's where I get involved, but also in supporting projects for blending hydrogen into natural gas distribution networks. So those are the two main areas of focus that Measurement Canada has had. As I mentioned, hydrogen is covered by the Electricity and Gas Inspection Act. So anything that is used for trade that uses our units of measure needs to be covered by type approval and ongoing verification. I mentioned that our regulations are trying to keep up. We don't currently have regulations about fuel dispensing for hydrogen. We're working on those. We have had for quite some time compressed natural gas dispenser requirements. We expect using OIML and those CNG approaches, they'll be very similar to what is required for hydrogen. One of the main issues with getting hydrogen dispensers approved has been the 3% limit of error. So regulation requires that all metering devices in use and operation need to meet a 3% limit of error under all in-service conditions. And a lot of the earlier hydrogen dispensers couldn't meet that. The approach that had been taken by all of the existing stations is some other form of sale to the public. So if they use a non-measurement based approach, it doesn't get covered by our regulation. So flat rates, a membership, other ways, pay by the minute, all of those that don't use a weight or a volume do not get covered. And so they're not currently approved under Measurement Canada acts and regulations. I know that in talking to industry representatives that a lot of the newer technologies are able to meet the 3% limit of error. We expect station owners to be applying, and we do expect to have approved equipment in the near term. We will have to update our regulations to meet those, and then we go through the type approval to have those dispensers type approved. A second area that Measurement Canada has been involved in is blending of hydrogen into natural gas distribution networks. So last year we had a policy, G25, which basically is put in place to allow these demonstration projects that distributors were wanting to run to go forward. What it says is that all metering equipment that has been previously approved for natural gas, if it's blending up to 5%, those projects can go forward. We'd like to be informed that those projects are going forward, but there's no restrictions on using that equipment that was previously approved. Higher concentrations, so between 5 and 10%, we are looking for either manufacturer's data or some other evidence to show that the equipment that's going to be used can accurately measure hydrogen. And then at higher concentrations, so 10% up to 20%, we expect a greater deal of work required, and we're expecting that either the manufacturers or the companies that are having these demonstration projects would apply for a type approval and would have approval of those meters to be able to handle hydrogen in those distribution networks. So I've shared a link. If you're interested, you can read more about that policy. I won't go into too much detail, but just wanted to say that there's a fairly involved approach when a meter is submitted for type approval. We basically require it to go through a verification internally, have marking and sealing requirements in place, have data that's generated through testing by us or a third party. And then through all of that, we can confirm that device is approved, type approved, and then that can be put in the field. From that point on, there's some ongoing verification requirements. But first approach basically is to contact Measurement Canada if you've got a device that is not currently approved and you'd like approved for use. Specific to hydrogen refueling stations, what we've been involved in is a lot of discussions with manufacturers of the equipment and the station owners or operators themselves, as well as international labs and international governments that are also involved in promoting hydrogen fueling stations. There's a small number of stations. As I mentioned, they're not currently type approved because they're operating a different way of selling to the public. And there's a lot of stations that are planned over the next few years. The issue for approval becomes that a lot of them are heavy duty stations. I know the focus of today is on light duty, but I know there's a lot of work on heavy duty stations as well. And it becomes harder to verify the equipment for heavy duty stations because there's a lot higher volume of hydrogen that's dispensed to a vehicle. One of the main things we're going to be working on is, and we've been trying, is purchasing a testing rig to be able to verify type approval and also ongoing verification of the dispensers at stations. We've got requirements that we're trying to publish to have that purchased. One thing I wanted to mention is, as I said, there are no plans right now to have that capacity for heavy duty stations or vehicles, but that's certainly something that's on the horizon in the future. So what's next? There's a great deal of work internally on updating our regulations to make sure that we can handle hydrogen dispensing and hydrogen blending in the networks. So that's a big part of our work. We are also updating our internal capacity by buying a hydrogen flow testing loop that'll be able to verify hydrogen meters for blending. And as I mentioned, trying to contract out to buy a testing rig for hydrogen dispensing stations. All of that requires ongoing discussion with manufacturers, operators, and industry representatives, as well as international partners. So there's a lot of work to do in this field, and we're digging through it. It's interesting for sure. Finally, left my contact information. If you've got additional questions after the meeting, happy to chat, and so reach out if you want to. And with that, I will pass it back and we can go to questions.
Thank you, Jeremy, and thank you to all the speakers today. I will be turning on your mics and cameras momentarily. All right, you can turn on your mics and cameras if you have questions or drop them into the chat. Inder?
Question for Jeremy. Where are you working to get the heavy duty fueling stations? Or the one station you were saying you're trying to get that up and running for a pilot. Where exactly are you planning on having that installed?
So we're only looking at light duty and medium duty verification testing rig right now. Are you asking where the heavy duty stations are planned to be built, or?
Sure. Yeah, that works.
So I think, I mean, I've got better people on the line than me that would have better information, but it looks to me like most of the work is in the West right now. So BC, Alberta corridors. And
Okay.
there's been a lot of public announcements on heavy duty stations and networks, but I don't have any more info than that. Maybe somebody else might have more.
I'd definitely be interested in piloting something like that. So I work for the city of Coquitlam. So we'd want to try like hydrogen type vehicles for like our snow plows, for tandem trucks. That if we could get something like that as a pilot, it'd be great.
I think my colleagues at Transport might be a better spot for something like that for what you're describing.
Okay.
Jared, you have your hand up?
Yes, thanks. Jeremy, I just wanted to a quick question around the dispensers in California have been operating for maybe 10 years now. Could you speak a little bit to the difference? Like, what is Canada looking for differently than what's being used currently in California, and maybe expand on that?
You mean in terms of what verification and approval will be required? We've had discussions with California, and the requirements for approving and ongoing verification of the stations would look very similar to those. It's because there's a small number of stations right now, we haven't had the verification equipment to be able to do an on-site type approval. So that's been a hindrance, but it would look very similar to what California has in place for their for approval of a station and verification.
Okay, I was just wondering, like the current, like the 3%, is that being utilized? Is that what's being utilized in California as well, or?
No, so that's a big difference. That is written into our act. So all measurement equipment needs to meet that level of accuracy, which has been a hindrance. And California has a system where they can have graduated levels of accuracy depending on the device. So that is a difference between our California and ourselves.
Okay, do you see that changing at all? Like, obviously,
It's
there's
very
53 some stations going, and they've got,
Yeah.
Thousands of refueling events and got some good history. And
Yeah.
I guess that's where potentially, I think a lot of times we're reinventing the wheel, and a lot of these things have been done, and I guess that's what my question would be around.
So all of my colleagues in government can attest that an act of parliament is not a short thing to change, because our requirements are written right into the act, and changing that is an extremely painful and slow process. I don't expect the 3% to be able to change. There's been discussions, but that's kind of a limiting factor.
Fair enough, and thank you for that. And just one quick follow-up question around if other methodologies, so if we go to flat rate and things that don't have a measurement of like a weights and measures, then that's kind of a workaround to be able to sell kilograms of hydrogen?
Correct. So
Okay.
we only get involved when it meets one of the units of measure we have by volume or weight or mass or so on. But so there are other approaches that don't touch on our, don't fall under our regulation. Correct.
Thank you very much.
Diego, you have your hand up?
Yeah, please. Thank you very much for the opportunity. I would like to ask you, we have here in Alberta some, is, low temperature, minus 40 Celsius degrees. How has been your results with this drastic low temperature? Because we know that it's very different from California, minus 12, 15, or minus 20 of BC, specifically here in Alberta. Thank you.
I think that might be a question for Cyril. I don't have anything on that one.
Okay, yes. Well, I was not sure if you could answer. So actually, the low temperature is for the metering accuracy is a bonus, as the station have to cool down the hydrogen in order to compress to deliver it to the car. So minus 40, minus 45 is it's okay, as that will reduce energy consumption for the chiller.
Emily, you have a question? Oh, we can't hear you.
Now?
Yes.
Fantastic. Firstly, thank you for the really interesting webinar and really appreciate your time. I have a question about the use of liquid hydrogen at refueling stations and where in the timeline you see that fitting in, if you see it fitting in at all.
I can take a short stab and then others if they want to comment. So we haven't seen anyone come forward with that plan yet. Perhaps in heavy duty, there's plans in that area. It's probably easier to measure liquid hydrogen. So in a way, it's simpler. The complex part comes between the connection to the car. But we'd be open to that if there are plans. Haven't heard any myself.
On the data analysis side, we identify that as a demand for hydrogen increase, especially in high density population, the storage of hydrogen at the refueling station become more and more important.
Brilliant, thank you.
Jared, you have your hand up?
Yeah, thank you very much. One quick follow-up question for Jennifer. On the LCAs, will the LCAs kind of work from a wells to wheel approach, or rather than just production? Because a lot of different methodologies have, incur a lot of transportation and distribution emissions. So could you just speak a little bit to that?
Yeah, great question, Jared. Really, it is focused on the different production pathways, specifically related to the bounce and the gate. I would have to defer to the principal investigator, Giovanna, but there's a webinar on this actually next week. So if you're interested, I can send you the information, and you can join and ask her yourself and see exactly where the bounds stop. Of course, the end use is very, very important, and but yeah, specifically how she gates that off, and I'd have to defer to her.
Great. Okay. Thank you.
Thank you to everyone for attending today's webinar. We are 1 minute over, so I will let everyone go now. I will send the recording of this webinar, the slide decks, as well as the contact information of all the speakers today. So if you have any further questions, you can email them. And then, as Jennifer mentioned, we do have an LCA Roadshow next week, Tuesday and Wednesday. I will also include the links to register for that in the email following this. All right. Thank you so much for everyone. Have a good day.
Thank you.
Thank you.
Yeah.
Thank you.
Bye.
Thank you.